Hello, good morning to all. So today I am going to discuss about the PCB, process control block. So PCB or process control block is a data structure that contains information of the process related to it, and the process control block is also known as task control block, an entry of the process table extra. That means, what is the process control block? This PCB contains, or you can say it is a data structure which maintains all the information of a particular process. So here the question is that there is one PCB, only one PCB for all the process present in the operating system, or you can simply say, is there any single piece or one single PCB maintain all the details of the details of the all processes, or each process having own PCB? There is answer is that each process having own PCB in the operating system. That means when a process enter into the operating system, there a PCB is created, and that PCB maintains the details of that particular process. Clear? So this PCB, what are the contents of this PCB? Now first is your pointer, process state, process number, program counter, registers, memory limits, list of open files. First is your list of open files. So let's look about the contents. First is your process state. It specifies the process state, that means whether the process in the new state, ready state, running state, waiting state, or execution state. Next is your process number. This it shows the number of the particular process, or the sequence number of the particular process. Next is your program counter. It contains the address of the next instruction that needs to be executed in the process. Next is your register. It specifies the register that are used by the process. They may include accumulator, index register, stack pointer, general purpose register. So these are the different register, contain the different type of register like accumulator, index register, stack pointer, and the general purpose register. Next is your what are the list of open files. These are the different files that are associated with the process. Scheduling information, the process priority, pointers to scheduling queue extra, is the CPU scheduling information that is contained in the PCB, and this may also include any other scheduling parameters. Next is your memory management information. The memory management information includes the page table or the segment tables depending on the memory system used. It also contains the value of the base register and the limit register extra. Next, IO status information. This information includes the list of IO or input output devices used by the process, and the list of the files extra. Next is your accounting information, the time limits, account numbers, amount of CPU used, process numbers, extra, all the part of the PCB accounting information. So that's why the PCB is nothing, it is a table or it is a data structure which maintain all the details of a particular process. So next we have to discuss about the IPC or inter-process communication. Inter-process communication, since process frequently needs to communicate with other processes, therefore there is a need for a well-structured communication without using interruption among process. So that is the there are two type of process, one an independent process and another one is a cooperative nature. An independent process is not affected by the execution of other process, while a cooperating process can be affected by other executing process. That means independent process means it is totally independent, it is not dependent with each other or on another process. So what do you mean the dependency? Dependency means suppose the output of one process becomes the input of another process, then there is a dependency. That means the second process is totally dependent upon the output of the first process. That means that means the second process wait the first process till its completion. So though one can think that those processes which are running independently will execute very efficiently, in reality there are many situations. In cooperative nature can be utilized for increasing computational speed, convenience and modularity. Inter-process communication or IPC is a mechanism which allows processes to communicate with each other and synchronize their actions. The communication between these processes can be seen as a method of cooperation between them. Processes can communicate with each other through both, that means share memory and message passing. That means in cooperative nature, sometimes definitely different types of process share a single memory. So that is the share memory. Message passing means one's output is the input of other process, right? So come to the what is the share memory method. In the share memory method, there is in the example, it is the producer-consumer problem. So what is producer-consumer problem? There are two processes. One is a producer, another one is consumer. Producer produces some items and consumer consumes that item, right? So the two processes share a common space or memory location known as a buffer, where the item produced by the producer is stored and from which the consumer consumes the item if needed. So here how the memories will be shareable. Now here is a beautiful example known as the producer-consumer problem. Now producer-consumer problem is that suppose there are two processes, one process acts as a producer, another process acts as a consumer. Producer produces some item and consumer consumes the item. That is the basic properties of that producer and consumer, right now. But these two processes share a common space, which is known as a buffer. That means this is a container where the producer produces items and place into that container, and consumer consume the items from that container. That means for both process there is a shareable memory through which producer produces the item and place in that container, and consumer consumes that item from that container when it is required. So there are two versions of this problem, you can say. The first one, unbounded buffer, and another is bounded buffer. The unbounded buffer, in which producer can keep on producing item and there is no limit on the size of the buffer, right now. So that means there is no limitation. Producer produce the items, there is no limit of the buffer. But in case of the bounded buffer problem, in which producer can produce up to a certain number of items before it starts waiting for consumer to consume it. That means in unbounded buffer, the size of the buffer, there is no limitation. That means producer produce as much as items possible, as much as possible. That means there is no limitation. But in case of the bounded buffer, there is a limitation. That means after the consuming all the items, then the producer produce the item. So that is the concept of the shared memory. So thank you for this class. For next class we are going to discuss. Thank you.